Hey, testing, testing, 1, 2, 3, 4. All right, welcome back. This is Scott. Hey. So let's do some basic concepts of matrix algebra in R. So I have RStudio pulled up, and so let's just go through some lines of code. This will be pretty basic, but let's suppose I want to create a well, I'm clearing my console. All right, so this first command right here, I'm going to actually construct a matrix, right? So I'm using a matrix function in R with the combine function. I'm going to do a number of rows of 3, and I'm going to do by rows. So if I do that, and then I express my output, there you can see what I did. So I have 278 on the top row, 110, 0, 4, -5. And that's what you see down here in the console. All right. So then if I want to construct just a vector, I can do that with just the C command itself. And I'm hitting, by the way, I'm hitting Control Enter when I'm doing this. And then I output that. And so I get a row vector 2, 3, 7, 8. Now I'm going to do a matrix of 1, 6, 5. I'm not going to put in the number of rows. Let's look what the default does. And then if I hit again Control Enter, I get a column vector, right? So if I use that matrix with no modification of the number of rows or anything, it defaults to a column vector. Okay, so now let's use the matrix just like we did above. The number of rows is 3. What do you think is going to happen? Well, what should happen is I should get a column vector, and that's what happened. Okay, so that's what happened. So by specifying the 3, I get the same thing as if I don't specify anything. The default is a column vector. All right, so then I'm going to create this variable e, and when I do that, I'm going to specify rows 1. I should get a row vector. Let's see what happens. I hit E and then Control Enter, and sure enough, I get a vector of 1, 6, 5. Now, there's a function called T, which is the transpose of E. So if I hit T of E, sure enough, that transposes that row vector into a column vector. So now let's look at some matrix addition, subtraction, and scalar multiplication. So the next thing I'm going to do is I'm going to create this new matrix. It's going to have 2 rows in it, and sure enough, it has 3 columns, 2 rows. So it's a 2 by 3 matrix. And then if I take the transpose of that, it is a 3 by 2 matrix. And so I'm looking down here when I execute. Hope you are too. All right, so the dimensions means what is the dimension? So I just set it, kind of give away the plot there. So the dimension of x is 2 by 3. The dimension of the transpose of x is 3 by 2. All right, so now if I put this matrix in, what do you think is going to happen? I'm adding 6 different elements. I'm creating 2 rows. So y is going to be a 2 by 3 matrix. Sure enough. Now, let's look at if we sum this x up here, right? This x and this y. If I just sum them, all I'm doing is I'm just adding element by element to it. In fact, let me just do this. Let me just stick them side by side so we can see x, and then we can see y. And so the first element should be 2 plus -1. Let's do, and that would be 1, right? So sure enough, if I look at this, 2, negative 1, 1, 3, 0, 3, 1, 0, I'm sorry, 1, 6, 7. So that's what I get there. All right, so if I take the difference of x and y, then x minus y, sure enough, I get the difference between x and y, and I'll get 3, 3, negative 5. That was x, which is 2, y, which is negative 1. So 2 minus negative 1 is 3, right here. And then 3 minus 0 will be 3. And then 1 minus 6 will be negative 5, etc. Okay. All right. So that's that. Let's see. Where were we? I think hang on just a second. Okay. All right, so that was the difference. Now, a scalar multiplication. So let's see. Right here, what I'm gonna do is I'm gonna take a scalar of 3 and I'm gonna multiply it by x. So here is x, or we could just do it again. Let's see what x is. X is that matrix right there, 2, 3, 1, 8, 0, 4. And then if I multiply it by 3, that's what I get. Each element is multiplied by 3. All right, so now element-wise multiplication, matrices must be conforming. So let's do something that's kind of cool here. I'm going to take T. I'm going to create this matrix again. So this is going to be 2, 3, 1, 8, 0, 4. And so if I were to list that out, that's what that looks like. And then, by the way, so, if you really want to see what these things are going to look like, you notice I've just been using a single line. If you want terse code, then you can do this. If you want to see what it's really going to look like, R doesn't care. You can actually just post a line to line to line. And if I do that, and I outline that and hit Control, then I've got U. And then if I print out U, U is going to be 1, 1, 1, 1, 1, 1, just like I had specified. Notice that, oh well, I kind of messed up. Number of rows is 2, so if I really wanted to do that, I'd probably do this. And then, make it look a little better, right? And then it would look like that. So in other words, the code kind of matches up with the way the thing looks. Again, R doesn't care if you do it this way. It doesn't care if you do it that way. So anyway, there's U, there's T. And then if I add the two together, then that's just going to be adding T plus U. So let's do a couple more things. So in R, if I multiply matrices together, then I use this operator right here, right? This operator, this percentage asterisk percentage operator, and I think that's the same in SAS IML. I used to do a lot in SAS IML, but anyway, let's look at M. And then we'll look at what M looks like. Make sure, I'll always like to make sure I'm getting what I think I'm getting. All right, so there I have a 3 by 2. Here I have a 2 by 5. And then I'm going to multiply these matrices together, right? So that's M by Y prime. Again, M, and then I'm going to multiply these together. And so now I'm getting 40 in here. So what's happening is I'm flipping this one right here. So I'm taking the transpose of it. So what I'm really doing is I'm saying 6, this 6 times this 2 plus 4 times this 7. All right, so that's 12 plus 28, and that's 40. All right, and then I'm just basically doing that across the elements. So that's where I'm getting those numbers from. Okay, and let's see where we are. Okay. I don't think I need any of that. So determinant is important in some mathematics. So again, I'm going to do a 3 by 3 here. I'm going to call it F. And so what is F? Just to be sure that I'm getting what I think I am. And I am. And so I do the determinant of F, and this is what I get, that little teeny tiny number. If I want an inverse of a matrix, here's G. And so G looks like that, just to be sure, and then solve for G. And then that's the determinant of G. And then even the diagonal of G. So, which is just essentially this, because you use this a lot, the diagonal, you use it in matrix algebra. So that's just that, those 3 elements you can see right there. It's all that is. All right, so and so another thing that I was going to cover, which is basic to R natively, is eigenvalues, eigenvectors, and spectral decomposition, which is sometimes used in multivariate statistical stuff. So if you check out my channel, it's just Scott Burke in YouTube. You'll see a video there. If you search within my channel, you'll find a little ditty on those 3 pieces. And so there are a lot of other functions as well in R. But most of them require, many of them require libraries, right? So you'll have to download a library like rank if you want to get the rank of a matrix, etc. You'll need to do that. So if you would, just please leave me some comments on what you like about this, what you want to see. I do a lot of statistical, machine learning, data science videos. So I hope you check me out. Please give me a thumbs up or a comment. I appreciate it.